Welcome to our skid control course. We hope you enjoyed the video and learned something at the same time. So, starting with skid control, the obvious question is, what is a skid? Well, a skid is defined as the loss of traction of one or more of your tyres with the road surface. And there's three causal factors to this: braking, steering, or accelerating. We'll start with the first one, braking skids. You can imagine driving down the road, coming over the rise, and there's a hazard in the middle of the road. Luckily this car stopped in time, but what happens if it was travelling faster? The problem is when you hit the brakes, the wheels lock. The wheels then lose all traction with the road surface. And as you can see in this video, it doesn't matter which way you point the front wheels, the vehicle will carry on driving in a straight line, often ending up with your car looking like this. Perhaps one of the most important safety features modern vehicles have is ABS, or anti-lock braking system. The system consists of a control unit and speed sensors on each one of the four wheels. These sensors monitor your speed on each of the wheels, and if one of them locks, the ABS unit realizes you have now lost control on that wheel and will release the brakes for a microsecond. It will then reapply the brakes. This means that you will never get into a skid situation, and this can be clearly seen here when we do straight line braking at 100 kilometers an hour. We're going to get to a braking point, hit the brakes as hard as we can, and let's see what happens between a vehicle that doesn't have ABS, which is this one. Here you can see all four wheels locked up. Now with a vehicle with ABS, now let's have a look at the difference with a vehicle with ABS. Hit the brakes as hard as you can and you'll see the wheels do not lock up. When you put these side by side, you can see there's a huge difference. And if you look closely, you'll see that the top vehicle is actually now completely out of control. ABS also works when you're braking in a curve. So the vehicle's going to go through the curve, hit the brakes as hard as possible, and again we'll look at the difference between ABS and non-ABS. So again, without ABS, as soon as you hit the brakes hard, the wheels lock up and momentum forces the vehicle off the road. With ABS, not an issue at all. Again, huge difference when you look at them side by side. Obstacle avoidance. Now this is what ABS was originally designed to do. Here we can see we've got a nice wet road, very slippery, and we've got an obstacle that we have to get around. Okay, so here we have without ABS, hit the brakes as hard as you can, full lock on the steering, and it makes no difference whatsoever. The vehicle continued straight. With ABS, it makes it look like a piece of cake. You still have full steering under harsh braking. What about braking on different surfaces? Here we have a road, slippery and non-slip, and what's going to happen is we're going to bring the vehicle down, hit the brakes as hard as we can, and see what happens. Without ABS, as soon as you hit the brakes, the wheels that are on the high traction surface cause the vehicle to spin out of control. With ABS, again, not an issue at all. Side by side, huge difference. So, prevention is better than cure. Maintain a safe following distance and adjust your speed to the environment. And if you do have to brake, hit the brakes as hard as you can. Let the ABS do its job. Just remember to depress the clutch when braking, because this will prevent the vehicle from stalling. Let's get into our steering skids. The first is understeer. Understeer always happens going into a corner. Here you can see the vehicle is approaching the corner. Unfortunately, momentum or inertia will always want to pull the vehicle in the direction it was going. Here you can see the front wheels are clearly sliding on the tarmac. They have lost traction. Again, wheels were turned, but the vehicle just carried on going straight. This phenomenon is known as understeer. It means that the vehicle is not steering enough, and to compensate for it, all you do is reduce your steering lock and ease off the throttle slowly. Do not apply the brakes. Oversteer. Oversteer results as a combination of steering and acceleration, and will always happen coming out of a corner, and the loss of traction is on the rear wheels. Here you can see the back of the vehicle sliding out as it exits the corner, and this is called oversteer. So, how do we control oversteer? Because the rear wheels have lost grip, the rear rotates, and our front wheels are actually now pointing in the wrong direction. And this is obviously so what you need to do is you need to counter steer and then slowly release the throttle, and again you do not apply the brakes. So what is counter steering? As you can see, we're going into the corner, and you'll see we now need to turn our wheels in the opposite direction that we were actually traveling in. So you can see we were going around a right hand side corner, but the wheels are now actually pointing left. If you don't do that, your vehicle will spin out. Last lesson of this video, apex driving. Now coming into a corner is always the danger zone for understeer, while coming out of the corner is the danger zone for oversteer. Basically where these two zones meet is the middle of the corner, and that is called the apex of the corner. You should always be doing your deceleration, braking and gearing down before you enter the danger zone for understeer. And you should only be accelerating after the apex of the corner or midway through the corner. Thanks for watching, and yes, we hope you learned something.